Yeah, so good evening, everyone. Good evening. Let's see audio video okay or not. Just wait 2 or 3 minutes, then we can start. Let's wait 2 or 3 minutes and we can start. Two or 3 minutes wait. We can start. Yeah, good evening everyone. Good evening. This is the first problem. This is the first problem of today's class. This is the first problem of today's class. Let's wait 2 more minutes, then we can start. Wait 2 more minutes, we can start. Just wait 2 or 3 minutes. And those people who joined already, please start working on this. Please start working on this. Those people who started, right? Those people who are already watching, yeah, please start this problem. Start this. Everyone is audio video okay or not verified? Audio video okay or not verified? Yeah, I think, yeah, let me start now. Today's date, let me write the today's date. Today's date is, I think, 24, 12, 25. 24, 12, 25. This is the today's date. Right now we can start. I'm starting now. Everything is ready. I'm starting. Good evening, everyone. Today's date is 24, 12, 25. Yeah, this is the first problem of today's class. RIC batch, Discrete Mathematics. This is the first problem of today's class. The number of combinations of truth values for P, Q, and R, for which the statement negation P implies double implies Q and negation P implies R is true. The number of combinations of truth values for P, Q, and R for which this statement is true. Yeah, can you try this? It's a very interesting problem. So remember, RIC course contain all interesting problem only. RIC course contain all interesting problem. Every subject 200 to 300 good questions will be there. Every subject 200 to 300 good questions will be there. Right? RIC course contain for every subject 200 to 300 good questions are there. I request everyone, please go through it. The number of combinations of truth values for P, Q, and R for which this statement is going to be true. Let me know if anyone knows the answer. Those people who are watching, can you comment in the comment section? Can you check once? Comment in the comment section. Comment in the comment section. The number of combinations of truth values for P, Q, and R for which this statement is going to be true. How many combinations this statement is going to be true? Best questions will be explained. Now see this one. This is going to be true. Everyone know, right? Double implies, right? It is a double implies. Double implies is going to be true. Let me write now. A double implies B. This is going to be true. Is true, right? So in two cases, A and B both true, or A and B both false, then only it is going to be true. So A and B both are true, then also it is true, right? A and B both are false, then also true. So please remember, So, right, so what I want to say is both false, then also true. Both true, then also true. That is the meaning of this. A double implies B is true when both the things are true or both the things are false. Right? So that is the thing. You should know first of all what it means when the double implies is going to be true. If anyone is false, right? Suppose that both are not same. If both are not same, it is going to be false. If both are same, true or false, doesn't matter. If both are same, this is going to be true. If both are same, left side person, right side person is same. Left side person, right side person is same. Then I can say double implies is going to be true statement. Right? I think now you got the clarity. Now let's go further. See this one. Negation P double implies, careful, Q end. I think negation is there, implies operator. So let me write now. Negation. So P, right, P implies R can be written as negation P R R. You can write like this also. Right? So next one. If you want, you can write the negation like this also. Negation P double implies Q end. Negation keep inside. Bring this negation inside. It will become, right? If you see this one, it will become P end operator negation R. It will be like this. So because of all are end operators only, you can write like this one. Negation P double implies Q end P end, right, negation R. Right? So be careful. Now come to here. Now come here. See this one. Both are right, left side, right side, both are false. Then it is going to be true. Next one. That is a one case. One more case. Both are true. Then also it is going to be true. Right? So both, right, this statement. Simply, I am not done anything. I just done the simplification. Just to do simplification first. I done this. So left, right is same. Left, right, both are false, true. Both are true, true. Right? These are the two cases. It is the case one. It is the case one. It is the case two. Let's see the case one. According to case one, left false means right also should be false. That is the thing what we have to prove. Let's try. Case one, I am trying. Let me use another color so that you will get more clarity. Let's see the another color. So if you go to the case one, see this one, case one. Negation P is false means from this conclusion is P is true. Left side negation P is false means P is true. That one substitute right side. So P is true. Na? I'm substituting right side. Can you see the right side substitution? Right side substitution I'm doing. So Q end, right, because the P is true, right? So let me write now. True end negation R. This can be written as, I think this is what Q, na? It is a Q. Q end, right? Q end true, right? Q end true and negation R. This is going to be Q end negation R. And one more important thing is, see this one. One more important thing is, remember everyone, this one you want to make it as false. This one you want to make it as false. Try to understand. This one you want to make it as false. How many ways you can make it as false? Check properly. Right? If the left false, if right also false, then it is going to be true. Right? So if the left false means negation P is false, means P is true. P is true. So if you substitute the P true right side, it will become Q end true end negation R. It will become Q end negation R. So I want to make this as false. The possibilities are going to be, right? How many possibilities? Let's check. How many possibilities are there? Check, right? It is the end operator. Be careful, it is the end operator. End operator means anyone false, false. Anyone false, false. Suppose assume that anyone is false, false, that is okay. But suppose assume that anyone true. End operator, anyone true, no. Anyone false, false. If both are false, then also false. Can you find out possibilities? Q and negation are possibilities. Right? So the one possibility is true, false. Another possibility is going to be false, true. Another one is going to be false, false. So in the case one, if you observe, there are three possibilities. Check one time. In the case one, if you observe, there are three possibilities. Right? So what is the case one? If left false, prove right also false. Then both false, false, na? Then it will become true. So left false. What is the meaning? Negation P is false, means P is true. Substitute the P true on the right hand side. Q and true and negation R. So which will goes to Q and negation R. This one you want to prove false. So the possibilities are true, false, false, true, false, false. So from the first case, three possibilities. Let's see the second case. Everyone observe second case. See this one. Negation P true. Negation P true means P is false. Right? Now P false, na? Substitute right side. What is the right side? Q and false and negation R. Now verify. This should be, right? You want to make this as true. It is impossible. This is true, it is impossible because one person is already false. So from this case, you don't get anything. From second case, this is the second case. From second case, I tried. Right? You will get the 0 possibilities. From the first case, you will get the 3 possibilities. So total possibilities are 3 possibilities. Right? The number of combinations of truth values P, Q, and R for which the statement is going to be true. Answer is 3. Check one time. Anyone having any objection? Let me know. This statement is true for how many combinations of P, Q, R? So remember, if anyone don't know, A implies B is true, right? In 2 occasions. Both, right? Both left, right is true. Both left, right is false. Right? This is the thing. Both are true. Both are false also true. Right? Now I started simplification. Right? Negation, which is there, I have not done any simplification. Implication, I written the implication meaning. Implication, another way of writing. P implies Q. Negation P R. Right? P implies R. P or Q? It is a P, na? It is a P. Q, P, R, right? It is a P. P implies R. Negation P, R. So negation outside is there. I send the negation inside. So negation P becomes a P. R operator becomes end operator, right? And R becomes negation R. So if you see this one finally, negation P double implies Q and P, right? And negation R. So case 1, case 2. Case 1, both left, right, false. Case 2, both left, right, true. If you see the case 1, left is false means P become true. Substitute P. Then it is going to be Q and R. Q and R should be false means there are 3 possibilities. Now one more thing is left, right, both are true. If left true means P becomes false. Substitute P place false. False end operation, anything is going to be false only. So there is no chance of right become true. So from the second case, you don't get anything. From the first case, 3 possibilities. From the second case, 3 possibilities. So total possibilities are only 3. I hope you got it. Question number 85. Everyone got it. I hope everyone got it. Yeah, I think Ankit is saying that, sir, I'm getting only around 60 marks in test. What to do for the time management? So Ankit, please rectify all your mistakes. Ankit, please rectify all your mistakes. You are getting now itself 60 means I think you done the very decent work, Ankit. Very decent work you done. Very good work you done. Yeah, please, right after every test is over, please analyze. After every test is over, please analyze. It will give more clarity. Right? I think every day try to improve one mark. Every day try to improve one mark. Weak areas, right? Just to make sure everything all right. From weak areas, make sure everything all right. Which identify weak areas and remove the weak areas. Identify, rectify. Please keep on do every day. Now let's go to next question. Go to the question number, right? Next question, next problem you can go. Can you go to question number 86? Try now. It is also a nice problem. Please try this. Question number 85 answer is 3. Question number 86. Can you try this? Everyone try this. Question number 86. Remember that is the meaning of RIC. RIC contain tough questions only. Right? Good questions. RIC contain good questions. So can you handle this? If F1, F2 and F3 are right propositional formulas or expressions over some set of propositional variables. Remember, F1, F2, F3 are propositional expressions. They are not variables. F1, F2, F3 are not variables. They are expressions over some set of propositional variable. Let us enter some set of propositional variable. Let us assume X, so X1, X2, X3. These are the propositional variables, right? On them by doing some operation, you got F1. On them by doing some other operation, you got F2. On them, you by doing some other operation, you got F3. F1, F2, F3 are propositional expressions over some set of propositional variables, okay? Such that the expression is contained F1 or F2 implies F3 is a contradiction. Remember, contradiction means, right, all false. That is the meaning of contradiction. Please be careful. This statement is a contradiction means, this expression is a contradiction means, right, after drawing the table for this expression, right, right, in the table, all false are there. To this expression, right, all values are false. That is called a contradiction. Then which one of the following are necessarily true? Which of the following are necessarily true? Yeah, please go ahead. It's a very interesting question. Let's see how many people will give answer. Make sure everyone will try. Try everyone. Yeah, someone is saying that at last 4 to 5 questions are left unseen. Ankit, tomorrow I will make one YouTube video. Tomorrow I will make one YouTube video. Right? Please see that. For you only I am making that small YouTube video. Please verify. Right? As soon as today's class over, I will make that video. Right? You can check, right, how to attempt the test series. I will make. You can see that. It will be really useful to you. Right? Fine. Tomorrow you can see our YouTube, right? You will get that particular video. Thank you so much for asking. Now, can you go to this problem? What is the answer? It's a very, very interesting question. If F1, F2, and F3 are propositional formulas or expressions over some set of propositional variable such that F1 or F2 implies F3 is a contradiction, then which one of the following are necessarily true? Right? So now let's see this. Very interesting question. Let's see this. See everyone. Make sure some X1, some X2, some variable, some propositional variable, X3 and so on, Xn. There are something. Over this variable, careful everyone, over this variable, I written some expression, but maybe I kept between all of them. I kept some operator. I got F1. How F1 came, that's okay. It is a F1. Right? Means over the propositional variables X1 to Xn, by doing some operation, I got F1. By doing some other operation, I got F2. By doing some other operation, we got F3. They are the propositional functions or propositional expressions. Right? By doing something, right? On all these people by doing something, on all these people by doing something, I got F1. By doing something, I got F2. By doing something, I got F3. Okay, that is fine. Careful everyone. So if you see the problem clearly, right, left side is F1 or F2. Left side is F1 or F2. And one more thing is F1 or F2 implies F3. Right? So, and what he said is, this is a contradiction, all false. Be careful, this is a contradiction. This is a contradiction, means all false. This is false. This is also false. This is also false. This is also false. Right? Careful. This is also false. That is the meaning of contradiction. Now, the question what he is asking is, what about F1, F2, F3? F1 or F2 implies F3, that is a contradiction. I can understand. But what he is asking is, what can you comment about F1, F2, F3? What can you comment about these three people? Because he is not given, he is saying that they are expressions. But what expressions? What exactly? Because if we didn't mention anything, we can assume whatever way we want. We can assume whatever way we want. And he's saying that, option A is saying that, option A is saying that, see, which one of the following is necessarily true? Necessarily. Right? So he's saying that F1, F2 are tautologies. Maybe, may not. F1, F2 are tautologies. Maybe, may not. I cannot give guarantee. I cannot say F1, F2 both are tautologies. I cannot say. At least one of F1, F2 is a tautology. At least F1, F2 is a tautology. I cannot say this. I cannot say. If you want, you can check. Third one is saying that F3 is a contradiction. He's saying that F3 is a contradiction. F3 is a contradiction. Right? F1 or F2 is a tautology. Now understand, very interesting. F1 or F2 implies F3. If you want this as contradiction, means if you want this as false, only possibility is true false combination only can give false. True false. So this should be true. This should be false. So no doubt at all, F3 is a contradiction. It should be false. It should be false. F3 is false. True false combination, remaining any combination if you take any combination, guarantee, right, you may not get a contradiction. If you want to get finally contradiction, so left should be true, right should be false. True false combination. So F3 should be false. But what about F1, F2? Yeah, I cannot say F1 is true. I cannot say F2 is true, but F1 or F2 is true. What is the meaning? It may be true, false. It may be false, true. It may be false, false. Sorry, it may be true, true. It may be true, true. These are the combination. So, right, F1 or F2 should be true. I cannot say F1 is a tautology. I cannot say F2 is a tautology. F1 or F2 is a tautology. True. So I think now if you observe clearly, true, false become true. R operator. False, true. It became true. R operator. True, true. It became true. R operator. Next one, right? Next one. True implies false. False. True implies false. False. True implies false. False. So like that. Like that he is saying. So I hope everyone got it. So answer is, I think in my opinion, answer is C and D. F1 or F2 is a tautology. F3 is a contradiction. At least one of the F1, F2 is a tautology. Need not be. F1, F2 both are tautology, need not be. At least one is tautology, need not be. But F1, F2 is a tautology, yes. F3 is a contradiction. Is a very, very interesting question. This question is a very, very interesting question. This is going to be very, very interesting question. Let me know if anyone having any objection on this problem. Remember, RIC contain nice questions only. RIC contain nice questions only. Please try to understand. It contain nice questions only. Question number, right? 85 over, 86 over. Let's go to 88. Let's go to 88. Can you try this? It's a very interesting problem. Let's see how many people will give. It's a very interesting, very interesting. Check one time. Everyone try this problem. Everyone try. Everyone should try this. It's a very, very interesting problem. Everyone try. It's a nice problem. It's a nice problem. Try everyone. Everyone, I request everyone, please try. I request everyone, please try. There are 6561 functions. F goes to X goes to Y, where size of Y is equal to 3. If X is a power set of A, then how many binary relations on A are possible, which are neither reflexive nor irreflexive? Can you try this? Very, very interesting question. This is going to be very, very interesting. I don't know how many people will give answer for this. This is going to be very, very interesting question. Check one time. It's a very, very interesting question. So remember, there are 6561 functions, right? From X goes to Y, where size of Y is equal to 3. So let me check. Everyone know, right? Everyone know. See this one. X goes to Y, number of functions are, if everyone know, X goes to Y, number of functions are size of Y power size of X. This is the formula for this. But size of Y is already given, so 3 power X is equal to 6561. 6561, remember. So we have to find out X value. If something there in the power, if you want to find it, apply log, right? Log, which base you have to apply? This 3 should go. So what is the answer? Log 3 power X base 3. Apply this. So log of 6561 base 3 apply. So then it will goes to, right? X is equal to log 6561 base 3. So try to find out what is this value. Try to find out. Everyone do calculation. What is this value? Log 6561 base 3. Everyone do one time. What is this value? Please check. I also calculated. So using calculator, you have to calculate. Please calculate. So if you do that, I think you will get the, 6561 can be written as 3 power 8. This can be written as 3 power 8. So it goes to log of 3 power 8 base 3, which will goes to 8. So size of X is going to be 8. Now you have to read the problem properly. You have to read the problem properly. If X is the power set of A, if X is the power set of A, he's saying X is the power set of A. That's right. Let me try this one. Let me try this one. Power set of A. X is equal to power set of A, which is going to be 2 power size of A. So X is 8, na? 8 is equal to 2 power A. So I think A is going to be 3. That is also okay. I'm thinking that everyone is comfortable till here. Right? Be careful, whatever he mentioned, I done it. Remember everyone, A contain 3 elements. A contain 3 elements. And one more, every statement here important here. Then how many binary relations on A are possible? Then how many binary relations on A are possible? So remember, A size 3, A size 3. Binary relation on A means, right? I think A goes to A. Binary relation on A. Let me write now. Binary relations. Binary relations on A is nothing but, binary relation on A is nothing but, right? So everyone know, any subset of A cross A is a binary relation on A. So how many possible? Any subset of A cross A. I think A contain 3. 3 into 3, 9. Right? All subsets. So number of binary relations on A is equal to, I think, what is the answer? 2 power 9, which is going to be 512. Because 3 cross 3. So power set. 3 cross 3 is going to be, right? You have to say Cartesian product. Cartesian product you do 3 cross A means A to A, na? A to A, 3 cross 3, 9 elements will be there. So any subset, so 2 power 9. So binary relations on A is 512. Binary relations on A is 512, remember. So until now what I done is I calculated the A size. I calculated A size and is asking binary relations on A. Binary relation on A means, right, function from A to A. Function from A to A. That is the meaning of binary relation on A. Why he said normally binary relation from X to Y, people used to say. Binary relation on A means, right, binary, right, relation from A to A. A contain 3, B contain 3. 3 into 3, totally 9 elements. So any subset of, right, that Cartesian product if you take, which is nothing but a one relation. So total, right? So 3 cross 3 contain 9 elements. 9 elements, 2 power 9, right? Any subset you take out of those 9, take any subset. So 2 power 9 subsets possible, which is nothing but a relation. So 512 binary relations are possible. Now the question is going to be, understand, out of them, how many are reflexive, how many are irreflexive, right? Remember 512, right? So you have to understand 512 total relations. How many reflexive, how many irreflexive, we have to verify. How many reflexive, how many irreflexive, we have to verify. Now I will try one small thing, understand. A cross A, understand here, A cross A if you observe, right? A cross A if you observe, see this one, 1 1, it's a, right, A cross A, 1 1 2 2 3 3, right, 1 1 2 2 3 3, right? Next one remaining, I think if you observe clearly, totally 9 people are there. Lastly 1 1 2 2 you done, so total 9 elements, like that 9 elements are there, like this, or 9 pairs are there. So out of these 9 pair, if you observe, right, A size is 3, na? These 3 people should be there, other 6 people. Totally 6 elements here, right? Total is 9. Total is 9. Right, if you remove these, 6 elements are there. 6 elements are there, right? So, but when you say it should be a reflexive relation. Reflexive relation means it should be there. These 6 people may be there, may not be there. 2 power 6. 2 power 6 are reflexive relations. Okay. In the similar way, A cross A, right? Here if you observe 1 1 there, 2 2 there, 3 3 there, and so on, 9 people. Like that, 9 elements are there. Okay. So these people are 6 elements. These are 6 elements. Okay, that is also. But in the case of the irreflexive, these 3 people cannot be there. Don't take one possibility. Here take one possibility. Here don't take one possibility. Remaining people you may take, you may not take. 2 power 6. So irreflexive relations. Irreflexive relations, right? So finally, if you observe clearly, right, the out of 512, the people who are reflexive, 2 power 6, 64. Out of 512, the people who are irreflexive, 64 people, right? So out of 512, the people who are neither reflexive nor irreflexive, so 128 remove. So it will goes to 512 minus 128. Check. 12, I think 4. 4. I think it is going to be 10. I think 8. So I think 384. 384. Answer for this problem is 384. It's a very, very good question. This question is a very, very good question. So it's a very big story. There are 6,561 functions from x to y, where size of y is 3. If x is the power set of a, then how many binary relations on a are possible? 512 possible. Out of them, neither reflexive nor irreflexive, 384. Reflexive is 64. Irreflexive is 64. Right? Reflexive, irreflexive, totally 128. Right? Out of total 512, 128 remove, 384. 384 people are neither reflexive nor irreflexive. It is a very, very good question. It's a very, very good question. Question number 88, very, very good questions. Like this, like this. Right? As Ria saying that 384. Thank you so much. Thank you, Ria, so much. Thank you. Thank you. It's a very nice question. Please verify. This is going to be very nice question. So first of all, find out. Size of y is given 3. So 3 power x is equal to 6531, 6561. Then the x value is going to be 8. Now he is saying that x is the power set of a. X is power set of a. So x 8, which is equal to power set of a, means 2 power a. So a will become 3. Now number of binary relations on a, how many? Right? Binary relation on a is nothing but function from a to a. Function from a to a. So a cross a, find out. 9 elements are there. Any subset you take, that is nothing but a relation. Binary relations on a is nothing but find out a cross a, which contain 9 people. Right? Out of 9 people, take any subset. So 2 power 9 subsets possible. So totally 512 total binary relations on a. 512 possible. Out of them, right? Reflexive means diagonal elements 1 1 2 2 3 3 should be there one way. Remaining people may be there, may not be there. 6 people. So 2 possibilities, 2 power 6. So 64 reflexive relations. Next one, out of these 9, right? 1 1 2 2 3 3 pair. It cannot be there because of it is irreflexive. Other people may be there, may not be there. So I think everywhere 2 possibilities, like there 6 times 2 power 6, 64. 64 irreflexive relations. 64 reflexive relation. 64 plus 64, 128. Reflexive or irreflexive. From 512 remove 128. So 384 functions are there, or 384 relations are there, right? Which are neither reflexive nor irreflexive. Exactly. It's a very, very good question. So let's move to next problem. Can you go to question number 90? Can you go ahead? Can you go ahead? Question number 90, can you go ahead? Everyone try this. Everyone try this one. Question number 90, everyone try. It's a very good question. Try this. He is saying that which one of the following is not 1 to 1. He is saying which one of the following is not 1 to 1. Can you try this? Can you try this? Which one of the following is not 1 to 1? Can you try this? Everyone try. I will give answer. Everyone try. Try everyone. Everyone try. Everyone try. Yeah. Hope everyone done. Hope everyone done. So let me give the answer. I'm giving answer. Hope everyone is done. Let me give the answer. Which one of the following functions, right? N cross n to n is not 1 to 1. Is not 1 to 1, right? Is not asking, which is not 1 to 1. What is the meaning of 1 to 1? Everyone now. 1 to 1 means everyone now. 1 to 1 means if you give A here, it will goes to B, assume. If I give A here, it will goes to B. Suppose if I give C here, it cannot go to B. It is not 1 to 1. A going B, okay. C also going B. It is not 1 to 1. It is not 1 to 1. So remember, 1 to 1 means okay. Left one, right one, right? Unique matching. Unique matching should be there. So if you see the option A, if you see option A, observe clearly. Observe clearly. If I give 1 2, if I give 1 2, it will goes to 2 power, right? X square means 1 square. 1 square becomes 1. 2 into 1 is 2. 2 minus 8 is 6. Minus 6. Okay. 1 2 also minus 6. So, right? So next one is 1 5 also minus 6. So 1 10 also minus 6. So it is not 1 to 1. Because the right result is based on X only. Y changing, right? Because remember here two people are there. N cross N. Left side is not one person. Left side two people. So A is fail. Let's go to B. Let's go to B. Right? See this one. 1, 2, it will goes to 2 and 1, 3, 3 minus 1 is 2. That is okay. 2, 1 also same answer. So it is also not. 1, 2 also, I think 3 minus 1 is 2. 2, 1 also, 3 minus 1 is 2. So it is not. Let's go to, I think B over, it is a C. Sorry for this. It is a C. Right? See, let's check here. F of x comma y is equal to f of x comma y is equal to x. So if I give here 1 5 also, it is going to 1. If I give 1 6 also, it is going to 1. If I go to 1 10 also, it is going to 1. So no. C also fail. Right? Let's go to D. Let's go to D. So if I go here, same thing. 1 5, it is going to be 1. 16, it is going to be 1. 110, it is going to be 1. So answer is A, B, C, D. It is a MCQ. This is a, right? Sorry, MSQ. This is MSQ. This is MSQ. This question is MSQ. Let me know if anyone having any doubt. Ready, sir? I have this doubt. You ask me, I will help you. Ready, sir? I have this doubt. You ask me, I will help you. Answer is A, B, C, D. Answer is A, B, C, D. Let me know anyone having any objection. Check once. Are you okay? Answer is A, B, C, D. Answer is A, B, C, D. Are you okay? Now let's go to question number 90 over. Go to the question number 91. Can you try this? Try this. A is equal to 1, 2, 3, 10. Minimum how many distinct order pairs from A cross A? We need to select to ensure that we can always find one of the chosen pair that gives an even sum when the numbers within the pair are added together. I think it is something like Pigeon hole principle problem. This problem is something like Pigeon hole principle problem. So I will check once, right? So remember, A contain 10 people. Remember, A contain 10 people. Remember, A contain 10 people. Minimum how many distinct ordered pairs from A cross A we need to select to ensure that we can always find one of the chosen pair that gives, so, right? We can always find one of the chosen pair that gives an even sum when the numbers within the pairs are added together. Okay. Now see this. One. Remember, it is a very interesting one. A plus B is even. Understand this. A plus B is even, right? A and B both are even. Or A and B both are odd. Remember, if both even, then sum also even. If both odd, then also even. Right? See, remember, A plus B is even. When both are even, their sum also even. Both are odd, then their sum also even. Remember, in these two cases, A plus B is even. A plus B even. If both even. If both odd, then also even. Try to understand. Then you have to remember. Minimum how many distinct order pairs from A cross A we need to select, right? So to ensure that we can always find one of the chosen pair that gives an even sum when the numbers within. So now I will try this. Listen, I will try this. See, make sure everyone. I will try one group. It's A1. A is this, right? I think A is this only. Yeah. A is this. 1, 2, 3, 4, and so on 10. Right? So now see the A1. 1, 3, 5, 7, 9. Let's see the A2. 2, 4, 6, 8, 10. Right? So I think if you observe clearly, A1 cross A1. So from these odd is there, here also odd is there. You take, I think here 5 people, you take 5 here. 25 pairs are there, which will give sum as even. One more thing, right? One more thing if you observe. A2 cross A2. Here also 5 people, here also 5 people. So remember 50 people, right? So 50 pairs are there, whose sum is even. Both, right? Both even you take like the 25, both odd you take like the 25. Totally there are 50 pairs whose sum is even. 50 pairs are there whose sum is even. But some people are asking totally how many pairs possible, sir? Ready, sir? Totally how many pairs possible? How many pairs possible total is A cross A. Right? A cross A. A contain 10 people. A contain 10 people. 10 tens, 100. Total pairs are, total 100 pairs. Total 100 pairs. So in that 50 pairs, even some pairs. I think remaining 50 pairs, odd pairs, odd, right? How it is, let me check here. A1 cross A2. A1 cross A2. A1 is how many people? 5 people. A2 is how many people? 5 people. Right? I think 5 5s 25. 5 5s 25. I think order will change also. A2 cross A1. Like that also you can do. This is also 25. So 50 pairs. Sum is odd. Okay. Until now everything is fine. Now understand. From these 100 pairs, I took one of the pair. One pair I took. So that may be, right? From these 100 pairs, I took randomly one pair. Their sum may be odd. Right? One more pair I took. Some may be odd. One more pair I took. Some may be odd. Continue 50. When I done first 50 times, there may be chance that these people will come. But if I take 50 one more time, compulsory it should be even only. So to guarantee, right? To guarantee one pair sum is even, you have to take at least 51 people. If you take only one, no guarantee. It may be odd sum. If you take two pairs, there is no guarantee. They both may be, right, odd sum. If you take one more 3 pairs, those three people sum may be odd. So there is no guarantee. But if you take 51 pairs, it is a guarantee at least one of them is going to be even sum. Right? Let's read the problem. Right, see this one. We need to write this one. Minimum how many distinct order pairs from A cross A. We need to select to ensure that we can always find one of the chosen pair that gives the even sum when the numbers within the pairs are added together. So answer is going to be 51. Answer is going to be 51 for this problem. Answer 51. Please check properly. Until 50 pairs, no guarantee. 51 minimum guarantee, one pair contain sum as even. Minimum one pair contains sum as even. Try to understand. Right? Until 91 we done. In the next class, we will do some more problems. Right? Here onwards, 85 onwards started. So 85 onwards started. So remember everyone, right? So many problems. See, these all problems we done in the RIC. Right? Approximately 200 to 300 good questions we covered. If you cover these, they most probably they only will come in the examination. RIC course contain every subject 200 to 300 good questions with video solutions. Best questions with video solutions. This is best for last 50 days. Last 50 days preparation, it is a best. EPT RIC course is best for last 50 days preparation. Right? So good offer also going on. Please utilize. Good offer also going on. Please utilize. Tomorrow at 7:30 we'll meet again. Tomorrow at 7:30 we'll meet again. Sir, this is sufficient to get because I am weak at DM. If you comfortable, Sumant, if you comfortable with all these problems, whatever we covered, right? Definitely it will make you, right, lot of advantages. From every chapter we covered approximately 20 questions. From every chapter we covered approximately 20 questions. Right? Every possible question we covered. It will be really useful. Right? I request you, please go ahead this course. This is definitely useful to you. Not only DM, every subject 200 to 300 good questions. Approximately you will find out 4,000 good questions are there. 4,000 good questions. 4,000 good questions are there. It is going to be very beneficial. Please go ahead. Right? Perfect. See you in tomorrow's class. Yes, I think from now onwards, every day one subject you can take. Right? Every day one subject you can take. You can cover the problems. First to start with, right? What are your weak areas? Those subjects you start first. Weak area subjects start first. Sir, I am weak in this particular subject, sir. That subject you start first. It will be really beneficial. It is meant for last 50 to 60 days purpose. This is meant for your weak areas you cover, then cover the remaining subjects. Yeah, thank you. See you in the next class. Yeah, bye everyone. Good night.